Greetings. Welcome to podcast 205. So in this one, we're going to specifically talk about a great relationship between the availability of nutrients and soil pH. And you'll see that there is some pretty great correlations that we can draw between how pH influences which nutrients are available. And we can certainly relate that to the different pHs or the different climate types where we find different soil pHs. So specifically, if we look at our instructional objectives on this slide right here, the stuff that we're going to cover in this screencast is just the second half of objectives. So what you're looking at in this slide is pH, of course, on the x-axis, and you could say that on the left, over here, we could say that that's like pH 4, and maybe on the right over here is pH like 8 or 9 or something like that. And then on the y-axis, we're looking at percent nutrient available. And so what we mean is that as we go up, our availability of nutrients is increasing. And what that means is that as we go up on this slide, the ability of plants to access a specific essential nutrient increases. So up here, right, these nutrients up here are going to be very available, and down here the nutrients are not going to be very available, meaning that they're probably going to be deficient in the soil environment and plants aren't going to be able to easily access them. So our plant essential nutrients follow very predictable trends in terms of the relationship that you see here. And so I'm just going to show you what those trends look like. So the first trend is the green line, and what that is showing you is that the nutrients that follow this trend, calcium, magnesium, potassium, nitrate, sulfate, molybdate, chloride, and boron, as you increase pH, right, their availability or the ability of plants to take up these nutrients here is going to increase. Some other nutrients follow the opposite trend. That is to say, at low pH, right, they're very high availability, and as you raise the pH, right, for copper, zinc, iron, manganese, cobalt, and nickel, their availability decreases. And I wish that I could get into the details of why that is, but if you're interested in that, then certainly you might want to take a class called Soil and Water Chemistry or Environmental Soil and Water Chemistry, and that's a 400 level class offered in the spring. So, think about that deeply or not so deeply. Anyway, there is another nutrient, right, that follows a different trend, and this is phosphorus. And so what do you see here with phosphorus? Well, what you see is that no matter what the pH is, the availability of phosphorus is low. So that just means that no matter what in the soil, plants are going to have a difficult time getting the phosphorus that they need in order to grow and to flourish. So another thing that we also see associated with these relationships here between the green line, the blue line, and then the brown line is that there's kind of an optimum pH for the average maximum availability of all these nutrients for plants. And that's kind of where the crossover is, right? And so what that is saying is that the ideal pH for plants, right, in terms of nutrient availability is 6.5. And the ideal pH range for plants to take up the nutrients that they need. So if we're going to, what I mean by range is that if we're going to say a range of pH values in the soil where our plant nutrients are on average most available for plant growth is pH 5.5 to pH 6.5. All right, and that's an important range to remember. What's cool about the periodic table of the elements, and I'm going to show you that in the next slide, is, so here's the periodic table of elements. We've admired it already for the elegant way in which our elements are organized based upon similarities and properties. It's called periodicity. But anyway, what we can see here is that there's certainly an organization surrounded around where we find our nutrients that have high availability under acidic conditions or low pH, right? And that would be the ones in the middle from manganese to zinc, right? And then the ones that have high availability as you raise the pH, and that's the ones in green. And then phosphorus, which no matter what the pH is, it's got low availability. So on, any exam or anything like that, you're going to have access to a periodic table. So what I'm saying here is that you don't need to memorize a lot of data, right, or a lot of information. But what you need to be able to do is use the periodic table to just make some spatial relationships between the nutrients that are available at low pH, the ones that are available at high pH, and then phosphorus, right, which is a little bit anomalous in terms of its availability. So here's an interesting fun fact, right, and that is to say that Kelly Slater, world surfing champion, do you know how many times he's been world surfing champion? 11. Crazy, but true.